Okay, has this started? Mm, I'm not sure. Yes. Okay. Hi. Perfect. So we can start now. I'll assume everyone can hear me. Hi. Perfect. So we can start now. Okay. Uh, cool. Uh, from last time, I believe I did a bunch of questions, but I ran them through my friend and he hated my solutions. He said like they are not optimized at all. So this time we'll try to improve on that and make them much more optimized, ideally. So let's see. I always like to have one session open of Claude so I can talk with it. So let's do that. Perfect. Now we are trying to solve this solution. I'm trying to solve this problem. Now we'll give it ours. Oh, wait, let me refresh. Select a stream. How do I open the chat? I know I can open the chat from here somewhere. Pop out chat. Perfect. So I can just take this, put this around here. Yeah, around here. So we'll keep it here. And we'll keep this here. And that seems reasonable to me. Perfect. Okay. What? Sorry about that. Okay. Implement a GPU program that given a 1D array. Okay, makes sense. So I need end threads per block equal to, oh no, 256, and blocks per grid equal to it's a 1D array. And sorry about that, there are some ants weirdly. I'm trying to fix. Okay, blocks per grid, got it. So that's n plus, but is that optimum? Well, that's the only solution I know, so for now we'll do that, and if it works we will try to figure out like more optimized solutions. So I'm just initializing this, which is not exactly a lot of work, but yeah. Set global void top k selection kernel. Now we want a const float star input because that's the input. Now this would change, so this is a pointer to input and output, int n and int k. Perfect. So now I can start this kernel here, top k selection kernel, and I can just give it the inputs, and then let us begin. So like the nice solution I'm thinking of is find the maximum. Wait, how many input can we have? We can have n up to 100 million. That's 100 million, right? Yeah. And k would always be less than 100 million. So the way I'm imagining it is, how many blocks are we having? find the block max. How do we go about that? Or we can have, instead of n, we can keep k here. What would that achieve? Because output length is equal to k, right? So I'm thinking, so the amount of blocks we have is the, no, but if k is less than 256. Oh wow, this is rather tough. So let's try to figure it out. I can apply reduction and get block maxes. So let's try that. Int gid equal to thread idx plus block dim dot x times block idx dot x. Wait, I need to search something. Okay, so ntid equal to thread idx. Perfect. So I can start a shared memory. I get okay, if I get the maximum value in each block, no, that's pointless. Let's try to think this. So I have block 1, I have block 2, and I get max 1 and max 2. But if k equal to 5, k is equal to 5, like let's say 5, and I have 10 elements here, 10 elements here, I still will need to interchange them, right? Okay, so getting the maximum value and adding that to output is possible. But later on, like how do I find the second largest value without running this loop again? Um, but I can just create an array. So I have, okay, I have an array of all block maxes, and the maximum of block 0, let's say I have that, I have, so max 2 is the maximum, and I can just keep appending that to output till it is larger than max 1. But then I'll also need to create a separate array, but okay, max the, how do I get all the elements that, Or can I just sort the array? Is there a way to sort, like something like reduction, but for sorting, like sort each blocks? Then I can do like a two pointer method, like INJ. So like keep sliding. Okay, this larger now. Move this. Keep sliding. That kind of makes sense to me. Let's see. Where are we? So I can sort each block. I honestly do not know how to write the code for that though. Okay, I have multiple kernels. Um, Sort block. But I cannot give it output, can I? Wait, I cannot even change input. I can make another array of length n, and I can change that and give that as the input. That sounds like a lot of waste, but I've run out of ideas. So float temp array. I always keep forgetting, how do you. So CUDA memset? No, it's malloc. CUDA malloc. You give the destination. CUDA malloc. Let's see. CUDA malloc. So give a pointer, right? What does this do? So it's star array, comma. How long? Size of int times n. Okay, CUDA mem set. CUDA mem set. CUDA mem set. Okay, yeah. So over here, yeah. So this is what we need to do. Array 0, and then just copy this. Dang it. Dang it. All of that mean. That makes sense. That makes sense. So I can just give this as the input, and this would give me the sorted array. That makes sense. Top K selection kernel. Then I can give this as the input, output, and K. Then I'll also. This takes float star, right? Might be wrong. I'm not sure why that is the case, so I'll need to check it up. But I'm pretty sure that takes float star. So this sort. Wait, I should write kernel. Kernel. It's just convention, Like you need not do it, but it is helpful. So I do it. Wait. Oh no, that is, yeah, this is const. Float star input, float star output, and we're gonna optimize the hell out of this solution. Like this is, I'm pretty sure, a pretty trash solution, the one I'm thinking of right now, but I'm pretty sure we can make it much better. Obviously I do not know how to do it, but Claude's gonna help us out. This is my solution so far. So okay, this makes sense. Now I just need to figure out how we can sort it. So I believe we need to start a shared temp array, and I believe that's how you do it. So temp array tid is equal to input. You know, I always forget ternary operator, so wait. So gid less than n. Yeah, that makes sense. Input gid. Wait, it's question mark, yeah. Otherwise, what do you want it to be? 0, yeah. 0 1. Wait, if it's negative, 0 can be, yeah, it's minus inf. Do I write infinity? It's minus inf, right? It's minus inf. Because 0 can be greatest if all of these values are negative, right? Like you can see here, it's negative value. So you don't want to put 0 there. And that makes sense. So now I have temp array that is in shared memory. And wait, is shared memory shared per grid or per block? I think it's shared per block. I'm not sure about that. Wait, I should write these questions down, right? Is shared memory shared per block or grid? Then why is it float star array? Like I'm pretty sure that is how you initialize it. I'm just not sure why. Now the reduction loop. No, is reduction gonna help? Can I sort this with the reduction? Let's say, okay, so now this is just, wait, you have a single array that you need to sort, right? So I can just apply merge sort or something, but there must be like a more optimized way of doing it. It will be fun to implement merge sort though, because I do not remember how to do it. So I know the whole idea of it. Let's see if I can think of something. So you have the whole array, you split it into 2, you keep splitting it into 2. Split it into 2. So there are 2 for loops as far as I remember. So I have an array, I split it into 2. I have to sort it because like you keep splitting it into 2. Where does the sorting happen? Sorting happens in the inner loop as far as I remember. Yeah, I'm just checking. Like my room's not not that clean, so sorting happens in the inner loop. Just search it, merge sort. Dude, I know how it looks like. Just give me the algorithm. Yeah, got that. What? God, these are not helpful at all. Or I'm just stupid. Oh shit, there's a parallel merge sort. Maybe this is what I need. Input array, output array, lower bound, upper bound, offset. What is offset? What's lower bound? What's upper bound? I have no clue. Let's just start with the simple one and try to figure it out. Copy array, that's what we did. So we got that down. Merge two sorted halves from A into a single sorted run into B. Well, that makes sense. Why the middle? The middle does not make sense to me. Hmm. Okay. Okay, so that keeps splitting. Oh, this is a recursive solution. Time. Okay. Okay. I have array begin plus end. So B, it finds B. I'm thinking of stack calls. Does it make two separate stack calls? Wow, this this should not be that hard for me to understand. I'm kind of ashamed that it does not make a lot of sense to me. Uh, you know what? What we're gonna do is we're gonna copy this and take it to our trusty old Excalidraw and try to figure it out. Okay. Let's see. This makes sense. Like, this is just. Wait. How do I? So copies array. That makes sense. Copies array. Mm, I always find it useful, like when you have examples with you, right? So let's start int I equal to, let's say 0, because that sounds like a good number to begin with. Int j equal to 4. I know I'm cheating, so let's maybe it's a better idea to start with the second one, right? So both have to be. A is the input, B is the output. So A is equal to 52781. B is equal to nothing. Now begin equal to 0. Makes sense. End is equal to n. N is equal to 4. That all makes sense. So you have input array, output array, the beginning and the end. Makes sense. No trouble whatsoever. So that is the base case. So like whenever you have recursive loop, you want a base case. So you give that to top down splitter. Makes sense. If end. So that is, let's start with 4 minus 0 is less than equal to 1. When will that be the case? When there are only 2 elements left. So that will get out. Makes sense. Oh, what do I do? Okay, wait. Return gets out when there are only 2 elements left, and that completely makes sense. I don't have any problem with that. Okay, now you want a middle one to split from. Makes sense. In middle, like I've learned this over my years, that the best way to imagine recursion is to always think of the base case. Can I do memorization here? I never learned those things, so I means like academically I had to teach myself those things. Very interesting. Divide by 2, so that gives me 2, and this will happen only once. Yeah, that makes sense. So top down split merge B is the output. B is the output array, because that is where we want to store the things, the things, right? So B becomes an input to the, wait, what? But B is empty. So okay, this is not in place. Did it say anything specifically about initialize and b with 0? Honestly, how did these guys even come up with these ideas? I'm not gonna lie. So let's see. Oh, we have copied everything in B, right? Ah, damn, stupid me. Okay, lol, stupid me. So this is not empty. Yeah, I was losing my head. So, um, this all makes sense. So essentially, in the end, you will have two blocks. Two 0 to A, split merge B to 4A, this will become top down merge B, 0. 2 comma 3, 2 comma 3 comma A, and oh wow, what was that? I've never okay, split merge, no, yes, 3 comma 4, yeah, that makes sense. 3 comma 4 comma A, and then these would come out. and go to top merge this. uh, Hello. uh, should I expand this? I don't know. It's better if I made a tree out of it, you know. Yeah, I can do that too. I can write tdsm b comma 0 comma 2 comma a. Over here we have 4, over here we have 2 comma 4, over here we have 2 comma 3. Yeah, we have 3 comma 4. Over here we have 1, no, 1 comma 2. Here we have 0 comma 1. All of this makes sense, perfect sense to me. I love the fact that they fixed this annoying thing where you had to keep clicking on it to change it. So this happens, now this returns, and then this goes to top down merge. And what does top down merge do? So wait, substack goes back here. So returns, 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 this returns. So only these two go to top down merge. Makes sense. TDM with values of what? So B 0 1 comma 2 comma A. So does that make sense? That makes sense. That does make sense. And this goes two, 3, 4. Okay, perfect. Now I have these values of TDM happens, that gives the output of this, and then TDM happens with 0 to 4. Of TDM. Makes sense. Now TDM happens to this with 0 to 4A. That makes sense. Can you do recursion with CUDA? How would you do that? the bigger question is, why can it not be done? It can be done, should be able to be done. Well, one should be able to do it, yes. So this makes sense. Anytime like there's only two elements, come back up, because we need three elements. Which kind of does not make sense, because as far as I remember, there was always an even split. But you can always have three elements and like interchange. Let's see. So now this is 0, 1, 2. Let's start with this. Okay, let's start with this. So let's start with this. So I don't like this here. So this. So I becomes A is B. If that makes sense, that's so wild. So B A equal to B, begin equal to 0, middle equal to 1, and equal to 2. B is equal to A. That makes sense. Wow, okay. B is the unsorted array. Over here. Okay, so it's fine, we'll figure it out. The harder the problem, the better the solve, It feels much more satisfying when you finally get it done. Let's see. Oh wait, I should be hiding that, right? How long have I been streaming for? I don't know. Let's go back. Oh, sorry about that. Wait, where were we? Yes, here. And I is equal to 0 and j is equal to 1. Now the merging part. This is where it gets fun. Kinda. There was a time where I could take out the big O of this. I do not think I can do that now. And is 2 plus k. You should write I plus. Okay, if I, which is 0, is less than 1, the middle. What's the point of writing j in? Wait, why would you initialize these? Oh, okay. They are pointers. They also change, obviously. Okay, let me make sense. What is I? I is the beginning. Wow. So let's see. Begin, mid, end. You have I over here. And j over here. While I is less than middle and j or J is greater than AI. And it's running in a loop, so when will J be greater than the end? How will J be greater than the end? Then I will not be. K would be 1. B1. Let's input our values. So this would be 5, 2, 8. Wait, am I stupid? Wow, I need a water break. Let's see. K 0 less than 2 makes sense. Increase K. That is what I'm having problems with. I usually write k plus plus, so I know the value of k will not increase before it goes into the loop, but when I know if it is plus plus k, it increases before it goes into the loop. So I would be 0, mid would be 1. 0 less than 1. The value of b1. Wow, I'm losing my head. I'll take some time. I'll think about this later. Meanwhile, let's see. Wait, can I just apply this? Oh shit, there must be a sort inside of CUDA. Oh my god, I'm so stupid. What do you want? I was thinking, why did I try to re-implement the whole sort? Maybe that's wiser. Like, I'll spend some time on it, I'll think, I'll understand it, and I'll do it again. Give me 1 minute. Thinking of flow. I'm thinking, correct? It's a favorite life. I guess. So what? Sorry about that. Let's get back. Um, okay. Shared memory scope is per block. Perfect. Makes sense. Gets its own independent copy of shared variables. Threads in block 0 cannot see the thread. Perfect. This is exactly why our two-phase approach makes sense. Um, I knew it. You want float star. Damn it. Yeah. It's a yeah, stupid me. Wow. Struck with two places? Oh shit. Sorry. That makes sense. Okay. Number of threads multiplied by int values. Wait, what? Negative infinity in CUDA. See, I told you I was sure it's. Told you it's minus infinity. I had an inkling towards it. Mm, because I remember doing it before. Ah! Wow. Wow, I'm losing my head. Wow, that is such a stupid mistake. This is blocks. And over here we'll also need to damn, we'll also need to give memory because and it cannot be the same, which is annoying. Let's see. How do I make these mistakes? See, this is what happens when you stop practicing CUDA for even like 3 days or something. Uh, CUDA free. Let's do CUDA free at least. So I don't want to forget. Like I've made enough stupid mistakes. Okay. Bro, honestly, I don't remember. access on the sort. Does CUDA sort that can use, or do I need to implement merge sort or something? Which I'm happy to do if I am just able to make sense out of this. I distinctly remember a time when this seemed easy to me. I miss those times. Still broken. You fixed the pointer. Type elsewhere, but not here. Still has no type and no size. Given your threads, what should that size be? See, I know that's threads per block multiplied by size of int, but I do not remember the syntax. So CUDA malloc dereferences an uninitialized pointer. So, oh, it needs the address of the pointer, not the dereferencing of the pointer. So that's and. Oh, okay. So I should replace that with and underscore array. Yes, that should fix it. Not ends. Wait, what? Where? Oh, yes. Never noticed that. I didn't notice that. Stupid me. Fixed it. Sorry, share. Bytonic sort. Do not know Bytonic sort? Teach it to me, please. Maybe I should have. Oh no. Like that. Oh no, me. Oh, it's fine. It's fine. Yes, CUDA is correct. It's just shared. Ah! Damn it. How do I keep forgetting this? But it's fine. We are all humans. We all make mistakes. Shared float temp array. Wait. Ah. What? What? Okay. What goes up goes down? Well, this sentence completely makes sense. Like this is, you just read it as like, yep, Yahtzee, figured it out. Um, Bro, I've been just doing it, so I don't read the term. Oh, okay. Is there any short article or blog on this that I can read? I've heard about this book. I've heard about this guy as well. The funny thing is, I don't know if it's worth reading it anymore. Beautiful. Short answer is I'm not reading that, so we'll just have to make sense out of this. बोलो भाई, हथौड़ा रखो उसके लिए स्पेसिफिकली. वही तो मत सोच लो, जलन हो गई मुझे. ऊपर राइट साइड
जहाँ मसाला रहता है.
यस.
मम्मा जहाँ मसाला रहता है.
Let's get back to this. 4K. What? Okay, comparison distance, halving each step. So that would be 1, 2. Well, please tell me. none of these. So I have a hard deadline of 12, so let's try to solve it on our own till then. If we aren't able to, unfortunately, I need to take a break and do some other chores that I need to resolve. Well, this turned out to be harder than I thought. Exactly. Makes sense. Okay. Well, this is truly longer. Uh, wait, did my cell phone die again? Yeah, it did. No, it didn't. Okay. Ah, each thread takes care of a pair. That makes sense. Okay, so it's follows a curve. Follows a curve. Okay. Lemma. That makes sense. compare at half the distances. Makes sense. Wow. A6547 swap 5467. Wow. That is absurd. Bottom up. True, makes sense. Is that? I believe that's base 2. It's power of 2. That's a. I know what is log n square, what is log square n? That's fine. Which is bad, you know. I would ideally like to be able to write the code on my own because. Oh no. Let's start small. Otherwise, else continue. Else return. Or I could just have put this in an. Out of sheer curiosity. See, like, it is really supportive. Claude tells me, "Hey, you got this. I explained it to you. You completely understand all of it." And over here, I'm like, "Bro, what?" No, this makes sense. Um, let's say we got this. Okay. Ugh. Okay. Outer loop k goes from 2 to n, doubling each time. I know how to write that. At least int k equal to 2, k less than n, k times equal to 2. It's a very common pattern, you know. J goes from to 1, halving each time. For int j is equal to k by 2 j divided equal to each thread handles one index I. and sort ascending kind of does not make sense to me, this part. I'll look into it again. Compare and swap. Array I partner 1 0. Thread IDX, that is per block. Oh, I know about that. Yeah, I'm like just so used to Python, you know, so sometimes I do forget that. It is more or less a bit of hand holding. I need to understand this, I need to understand the direction thing. Now plug it into the original solution. Wow. I need a 5 minute break. I need a 5 minute break. How do I pause this? Best from best is like I leave things on. Hello. Right. What the? Supposed to be like all easy things. That is the whole point. Form those new neural synapses. Okay, we are back. Let's see. Um, where were we? We were trying to figure out what any of this means. Load from global memory into shared memory. Done. Sort on shared memory. So I just need to. Okay. By tonic. Do you need to do any kind of allocation? I'm not sure. 286. Let's see. Okay, now I gotta write this back to global memory. This back to global memory. Write this back to global memory. Just inverse this. Uh, does that fix it? I don't need to throw in a sync threads, right? Like sync threads at times are like it's so random. Where do you throw it? Do you just like, hey, I want to add a sync threads to it, like, just throw it there? It's funny. Uh, Two issues. Knew it. Try to move the loop logic into where? What? Yeah. Oh, shit. Told you it's sync threads. It's always goddamn sync threads. Uh, every block gets its own share. It's not float star. It's float star array that gives you a pointer. Got it. Okay. Is this fine now? What do I do? Well, I kind of know what I do need to do next. Like, once you have it sorted, uh, but these are sort per block. Now I need to write this part. Wow, which does not seem to be very straightforward either. Uh, I have no clue. Sometimes I imagine how much harder it would have been to do all of this and learn all of it if you didn't have a tutor. Oh shit, what do I do? Sometimes you make these stupid mistakes and you're like, I could have figured it out. But you get exhausted. So, mm, can I do a mapping? Store index and elements, like two list approach. Approach comes to my mind. Um, Firstly, each block. Uh, well, that's my deadline. I will think of the solution, post it later. Thank you for joining. Bye bye.